Hey, welcome back. Today I'm going to be going over this SAT geometry question. And once again, thanks to Anico.ai for providing this question in their free resources tab. But before I get started, please try this for yourself. Alright, so here we have a equilateral triangle ABC, where point D lies on segment BC, as you can see on the diagram here. We have this given ratio. So now segment AD is drawn. Which choice gives a measure of angle DAB? So we're trying to find, right, our end goal here, the measure of angle DAB. And if you see on the diagram, that's this angle. Actually, I'll call that question mark. Okay, so right away, if you think about it, like there's really two things we're given in this problem. We're given that this is an equilateral triangle, and we're also given that there's a ratio of this, right? BD over BC equals 2 minus root 3. So anytime you have a ratio, right, and you have a geometry problem, I think your best bet is to express that ratio in terms of variables instead of just plain numbers. What do I mean by that? Well, BD over BC, well, it's also equal to 2 minus root 3 over 1, right? And actually what you can do is say this is 2 minus root 3x over 1x, right? Because if you think about it, x here cancels out. It's just really a scale factor, right? Now, you might be thinking, well, why are you doing that? Because now what you can do is set BD equal to this and BC equal to this, right? So let's do that. So if BC is x, right, and BD is 2 minus root 3x, right? So again, 2 minus root 3x. Well, because this is an equilateral triangle, right? What does that mean? Well, we know all the angles are 60 degrees, so let's work with that. We know these are all 60. All right, and again, these are all 60. Well, if this entire angle is 60, well, then this question mark has to be smaller, right? We can make at least that assumption. So the answer choice cannot be D, right? Because it has to be smaller than 60. Okay, but how do you actually go about finding this angle here? Well, what you can do is draw an altitude straight from A, right, to the base of the triangle, BC, right? So this becomes a right angle here. You might be wondering, well, wait, why are you doing that? This is why, right? This is where my entire method of saying sticking to x, right, actually helps out a lot, right? When I say sticking to x, it means express every single side in the triangle in terms of x, right? And because this is equilateral, right, if BC is x, right, if this entire thing is x, well, because all sides of an equilateral triangle are equal, this is also going to be x, right? Right? Okay. And now what? Well, if this is an altitude, right, you get that there's a bisection, right, at the segment. So that means this is going to be half of the total side. So this is going to be x over 2. And same thing here, right? This here is also going to be x over 2, right? Because once again, this altitude here is bisecting BC. Well, now what? What else can we express in terms of x? Well, we know this is 60 degrees, right? Well, if this is 60 degrees and this is 90, well, that means this angle here has to be 30 degrees, right? because a triangle has 180 degrees in total. So we have 60, 30, 90. Two things. First, you'll realize that's a very useful ratio to know, right? 30, 60, 90 triangle. Second, if this entire angle here is 30 degrees, right? That means this question mark has to be less. So you know that the answer choice can't be 45 degrees and it can't be 30 degrees, right? So right away, you're kind of already going alluding, right, to answer choice A here, right, with that logic. But let's keep on doing this problem because I have to show you that there's actually a mathematical way to do this. So if this is 30 degrees, right, and 30 degrees is opposite x over 2, which makes sense, right? 90 is x, well, 60 is going to be x over 2 times root 3, right? This goes back to a 30, 60, 90 triangle, where if you have a 60 here and a 30, well, this is x, right? The side opposite 30 is half the hypotenuse. This is x over 2. And the side opposite 60 is the side opposite 30 times root 3. So it's x over 2 times root 3. That's where I'm getting this kind of, these values from. All right, now, how about this side? Well, if this entire thing is x over 2, and this is that, then this is going to be a difference, right? So this is going to be x over 2 minus 2 minus root 3x. Now, why is this useful? Well, think about it this way, right? If this is 30 degrees, right? And if we know the measure of this angle here, then you can find the measure of this angle, right? Because that's just a difference. But how do you find that orange angle? Well, think about it. We have every side here, or we have the opposite side of this angle in terms of x, and we have the adjacent side. So what you can do is use a trig ratio, right? If you have tan, and let's just call this angle A, tan angle A, well, tan, right, if you think back to SOHCAHTOA, is opposite over adjacent. The opposite side here is that, right? I'm just going to copy this. So, once again, that's the opposite side over x over 2 root 3. And actually, I'm just going to write the entire thing because for some reason, there's glitching involved. But, all right, okay. So, now, what are we left with here? Also, yeah, that's a 2 minus root 3, right? Yeah, okay. Make sure you're double checking every single time when you're writing these expressions. Okay, so now our end goal is to find angle A. Well, this is where you do tan inverse, right, to get the angle A on the other side. So, what I'm going to do, go to Desmos here, type in tan. For inverse, you do to the -1 power, and it gives you inverse right away. Type that fraction in, right? So we have x over 2 minus 2 minus root 3 x over x over 2 times root 3, right? And you'll see on Desmos that, well, this value, right, that y value is always pi over 12, right? So no matter what the x value is, right, the y value is pi over 12. The reason is because remember I told you earlier that the x is just a scale factor, right? Because so those x's actually cancel out, and they essentially what you have is a tan inverse of a consistent ratio, and that gives you pi over 12. So now we know that angle A is pi over 12. Well, what is pi over 12? Right, that's in radians. How do you convert a radian to degrees? Well, you multiply by 180 over pi, right? And that gives you 15 degrees. So That's how you also get the answer, right? 50 degrees. So once again, what's the main thing to realize about this problem? Well, as you can see in the diagram here, as I've shown, you should put everything in terms of x's, right? Because when you do, you'll realize that x is just a scale factor and you can cancel it out, right? And it'll help you find the measure of that angle. And of course, you can also just circle your answer and move on the second you realize that that blue angle, right, the question mark, has to be less than 30 degrees, right? I did all this math just to show you how you would actually get your answer by showing work. But hopefully that made sense. If it didn't, please leave any questions you have down in the comments, and I'll see you next time.